Okay, number 5 here. You have a choice between going to an in-state college where you would pay $6,000 per year for tuition and an out-of-state college where the tuition is $9,500 per year. The cost of living is much higher at the in-state college where you can expect to pay $750 per month in rent compared to $400 a month at the other college. Assuming all factors are equal, which is the less expensive choice on an annual 12-month basis? All right, how about this? Let's get this into two different categories. Let's say the in-state and how about the out? In and out. Okay, let's list these expenses here. So at the in-state college, you would pay $6,000 per year for tuition. Let's go, the in-state is $6,000. And an out-of-state college where the tuition is $9,500 a year. Let's list those accordingly. The cost of living is much higher at the in-state college where you can expect to pay $750 rent per month in rent. So that's going to be $750, and let's call it times 12. Compared to $400 per month at the other college. And the other college is $400 a month. 400 times 12. Okay. So let's compare the monthly, the expense. What is the question here? The yearly expense of the in-state college is blank and the yearly expense of the out-of-state college is blank. Thus, on an annual basis, the less expensive choice is blank. Alright, so we just have to figure what the cost is. So this is the yearly expense is $6,000. So this is $6,000 plus 750 times 12 is 9,000. Zeros on it if you want. So we've got 15,000. The yearly expense of the in-state college is 15,000, and the yearly expense here is going to be the 9,500, and plus we'll add 4,800. 0, 0. Thus, on an annual basis, the less expensive choice is the out of state. Okay, problem number 6 coming right up. Suppose that you currently own a clothes dryer that costs $25 a month to operate. Okay. A new efficient dryer costs $540 and has an estimated operating cost of $15 per month. How long will it take for the new dryer to pay for itself? Alright, so let's compare these. You got an old dryer, it's wearing out, and it costs $25. It's already paid for, but it costs $25 a month. So I could write that up as $25 times M for month, each month. So after 1 month it costs $25, after 2 months it costs $50, 3 months $75, etc., etc. And I want to get this equal to what it would cost for the new dryer. So the new dryer, we have initial out-of-pocket cost of $540 plus it operates on $15 a month. So you save $10 a month each month if you buy this new dryer. And I'll label this for M. Okay. So now using algebra, I have to solve for M. I want to get M to be by itself, and I want it to read M equals something. Okay, and what is that something? So in order to solve for this, we are going to subtract the 15M from both sides. Okay, I've got 10M equals this 540. Divide both sides by 10. And M equals 54. Which means it'll take 54 months for that new dryer to pay for itself. You know, almost, was that 5.5, almost 6 years, 5.5 years. Okay, that's how you do number 6. Okay, for problem 7 here, it says to evaluate this expression. And notice what it is. It's 4 raised to the negative 2. Okay, and 4 raised to the negative 2 does not equal 4 to the positive 2. Okay, so that means something's going on here. So, you know, without a big explanation for it, because we've only got a couple of these, I want to use the calculator. Use the calculator, and for this one, push 4, and then there is a caret, what we call the caret, which is right here. And it should read 4 with the caret, like this. And it's raised to, and then hit the negative sign for the negative 2. So it'd be negative and then 2 to the negative 2. However that comes out on your, I think mine is a little box. I have the TI-84 plus, and when I hit 4, the caret, and the caret just brings it up to the box. So on my TI-84, it reads like 4, and then the little box comes up when I hit the caret. Then inside the flashing box, you'll hit negative 2. And it should then come out to equal 4, or read 4 to the negative 2. Okay, then once you hit enter, you get 0.0625. Okay, so this will always give you a decimal number. Now from here, we've got to change this number to a fraction. Okay, so let me change colors here, and to put it as, how do I get to the fraction? So I want to hit this math key, which is under the alpha key. There's the math button, and once you hit the math button, then you're going to have to hit number 1. So I'll write it down here, math, the math key, then hit number 1 where it says fraction. You can hit 1 or the fraction. Okay. After you hit number 1, or enter I should say, then you can hit enter again. And that should give you an answer of 1/16. Okay? So remember, first you're going to go to the decimal number, and then change the decimal to a fraction by following these steps here. Okie doke. Okay, here are some problems from pre-algebra, some simple equations that we'll solve for the variable 4. Alright, let's just do number 8. p minus 4 equals 28. My goal is to get the p by itself. So here I want to add 4 to both sides. Add the opposite of the number so it disintegrates, it goes away. Negative 4 plus 4 is 0. Then I can just bring the p down. Equals 28 plus 4 is 32. Okay, so my answer is 32 for this one. That's number 8. Number 9, I'm going to re-jot it down here. 8x minus 3 equals 69. Okay, in this case here I want to work on getting the x all by itself, but first I want to get rid of any plus or minus signs, meaning this negative 3 has got to go. How do I get rid of it? Add 3 to both sides. And I end up with 8x, that equals 72. Now to get the x by itself at this point here, I'm going to divide by 8. So x equals 9. Okay. Whoop. Get out of there. Okay, how about number 10 here? What is this? 5y plus 8 equals 4y minus 5. I got y's on both sides of the equal sign, so I want to take the one on the right and get rid of it and put it on the left. So I'll subtract 4y from both sides. I end up with the left side being y plus 8 equals negative 5. And now since I got the y on the left by itself, I want to get rid of the 8 that's with it by subtracting 8. And I end up with y equals negative 13. Okay, and done with that. All right, one more. One more here. So let's see, I've got 8x plus 2 equals 6x plus 24. Okay, I'm going to subtract 6x on this side, get rid of the variable on the right side. And I've got 2x plus 2, that equals 24. Subtract 2 on both sides. 2x equals 22. Divide both sides by 2, and x equals 11. Okay, number 12, calculate the amount of money you'll have at the end of the indicated time period. So we're switching gears here a little bit, going back to simple interest I see right here. Simple interest. You invest $3,000 in an account that pays simple interest of 6% for 20 years. All right, so we need that simple interest formula of the interest. Interest equals, I'll make this an I. Interest equals the principal times the rate times time. And fill it in. The amount of money you'll have at the end of 20 years. So we're going to have to include the principal here. So I'll show you what I mean. Let's figure out how much interest we'll have. So the interest will equal 3,000 times the rate, which is 0.06, times the time, which is in years. So that's going to be our 20. Okay. I calculate this out, and that comes to be the interest equals 3,600. I could write it as the interest equals all this here is 3,600. Okay, how much The amount of money you'll have at the end of 20 years, though, is the $3,600 plus the principal of $3,000. So altogether, you're going to have $6,600 after the end of the 20 years. Okay. Number 12, number 13's next. Okay, here's another. And what do we got here? Calculate the amount of money you'll have at the end of the indicated time period again. Keyword there, simple interest. So we've got 3,000 times the rate of 0.034 times 15. That's going to equal our interest. Okay. So the interest equals 1530. And then plus the 3,000, the principal amount. Because again, we want to calculate the amount of money you'll have at the end of the indicated time period. Not how much interest are you going to get. Two different problems. But you add these up and you get 4530. Okay, that's an easy problem. Easier. I hope they're getting easier. Okay, starting with our next problem, number 14, there's some preliminary work that we have to go over. Okay, and I have to explain some things to you. And it's going to start with the notion of compound interest and the different terminology that we use. I've directed you to a handout that is online with some examples for you to use, and also with the terminology, but I'm going to go over it here with you again to remind you. And it goes something like this, where when we are compounding we need these terms that indicate what numbers to use that are associated with these compounding terms, such as, let's start off with something that is done annually. Annually. How about something that is done semi-annually? What number is associated with these terms? Next, it may be quarterly. We have accounts that are compounded, savings accounts that are maybe compounded quarterly. We also have maybe monthly. I'll go back over these and direct the number that's associated with it. Weekly. Something's compounded weekly or daily. Okay, so in our word problems that we're coming up, we're going to have this where it tells us that our investment is compounded annually. And what does that mean? Annual means one time per year. One is the number we're looking for, one time a year, annually. Semi-annually is 2 times per year. Quarterly, 4 times per year. Monthly, probably the trickiest because it just says monthly, and we're looking for more than that sometime, but monthly is 12. All loans are compounded monthly because we have monthly payments. Weekly, which we don't use, I just threw this in here, but if it were weekly, then that would be compounded. What number is that? 52. 52 weeks out of the year. And many accounts are compounded daily, and the number for daily we associate with respect to the year is 365. Compounded. Okay, so those are some terminology that we want to get used to. Also in the handout, it goes over with you what the calculator is going to be used for in solving these. And we are using the calculator. We're not using the formulas that they give in the book. You're more than welcome to do it that way. However, I'm doing the using technology, make our life easier by using this calculator. All right, so I'll direct you real quick here. And that is when I want to use the compounding feature of the calculator, I want to start with using the apps key, which is on the TI-84 calculator. Okay, I'll go over this with you in class to make sure you know how to get to it. And the apps key is located, let's see, next to the math key, kind of like the second column, third one down. So you want to hit your apps key. Apps. Okay, from there, after you hit your apps key, number 1 is finance. And you want to hit finance. Hit the enter key for finance. Number 1 again is the TVM solver. So again, you want to hit enter on the TVM solver, or number 1, TVM. Okay, and then you have this magnificent array of terms here, and it begins with, let's see, I'm going to switch colors here to go, N, and I'll explain this as we go. N is the number of compounds that we'll be inserting into this category. I, with a percent sign after it, is the percentage involved in the problem. Okay, I'll shorten this up. I'm just going to write I after a while. Next is something called PV. PV means the present value. Present value of an investment, perhaps. Present value of a loan amount that you're taking out. After PV is PMT. That's payment, for when we're figuring out the payment for a loan. FV, some problems involve us wanting to figure out, given a future value, for example, if we needed $100,000 in 10 years, how much do we have to have now? And then that we'd have to invest to achieve that goal. So sometimes we have future value problems. And then this PY and CY down at the bottom, this is for the number of compounds in the problem per year only. Just per year only. These two numbers will be the same always, because it's like period a year or compound a year, which mean the same thing. So these numbers mean the same. Okay, I'm going to take this chart with us everywhere we go in solving all our compound interest problems. Okay? All right, so let's go back to number 14 and start using this. Okay, so here we go. Very exciting time with the next few problems. So you'll be challenged by this, so really think about what's going on here. Okay, so we've got use the compound interest formula. There goes what I told you earlier. They are explicitly telling us compound. And then when we have compound formulas, we bring out this chart here, which is, through the calculator. Okay, the more you do this, the easier it becomes too, by the way. All right, I want to emphasize that because it does get a lot easier. All right, so here we go with problem number 14. Use the compound interest formula to compute the balance in the following account after the stated period of time, assuming interest is compounded annually. Okay, so we got our annual word for annually, meaning the number 1. Okay, also on your calculator on that table, I forgot to mention this. At the bottom, it says begin and end. Always keep it on end. Yeah, always keep it on end. We're not using the ones with begin. So, okay. All right, so let's try it out. I've got $11,000 invested in a APR of 3.4% annualized per year for 21 years. All right, so I need to know how many compounds are there. So we know that it's one time a year for 21 years. One time a year for annually times 21 for each of the years. You can plug this into your calculator as you see it, and it'll calculate it for you. So, I mean, that's easy enough. 1 times 21 is 21. So then it'll automatically compute that for you once you hit enter. Okay, interest is the 3.4%. Now, here's what's different than doing it the other way with a simple interest. We can just plug in 3.4. We do not have to change it to decimal. Okay, so just 3.4 is 3.4. The present value of this investment is $11,000, which makes sense when you think about it, because we always want to know how much is it going to be worth in X amount of time. So our $11,000 is invested for 21 years at 3.4%. The payment does not apply, so make sure you have a 0 in there. Don't leave it blank. If you leave one of these blank, then it's not going to work. It'll tell you it's an error. You have to have something in each of these categories. So payment is not being applied here, so we're using it as a filler, as 0 as a filler. Future value, that's what we're solving for. That's what we're solving for. And we're going to use our color-coded key here, the alpha key, for this future value. Okay? PY and CY, that's referring to, especially compounds per year, or periods a year. Compounds per year is this number here, the 1, that refers to the word annually. So 1's going to go here. You plug in 1 for the PY, toggle down, the CY comes in automatically. Okay? And what's going on here now? So that's it. Everything's filled in, and now how do I compute FV? I want to go up to the calculator, and after everything's filled in, you're going to toggle up to FV, and then the cursor will be flashing there, and then you're going to hit your alpha key, that green alpha key, and then enter. Okay? And when you do that, the answer you should get is $22,198.52. We round to the nearest cent. Okay? Don't exclude the cent. That means a lot. Okay. That's our first endeavor here, using the compound interest formula. Okay, here's another one, real similar to the number 14, but let's continue and go through this. So we've got N. Here's the compound interest formula to compute the balance in the following account after the stated period of time, assuming interest is compounded annually. Okay, let me get something to write with here. Annually, oops. 11,000 invested, APR or 3.8% for 18 years. 18 years annually, 18 times 1 is the N. 18 times 1 is 18. Interest, 3.8. Just filling in this chart. Present value, how much was the investment? Okay. Payment, doesn't apply. Future value, That's what we're solving for. So I'll stop doing this, but you get the point there. I want to color code it for you. PY and CY annually, so it's 1 and 1. So we're solving for future value. You will hit alpha, enter, and your answer for that is going to be 21,000. Whoop, I'll do it here. $21,525.09. Very good. Okay, next. See what we got here. Get the right rating tool. All right, we've got $15,000 invested for 8 years with an APR of 2% and quarterly this time, compounding quarterly. So N is going to be the 4 for quarterly times the number of years, which is 8. Okay, get that situated there. That's the hardest one to figure out, really. Interest is 2. Present value for this investment, $15,000. Payment is 0. Future value, that's what we're solving for. PYCY, now that changes. Remember, it's quarterly compounding. For the compounds per year is 4. Now we can go ahead and solve for the future value. And what is this, 16? So for this problem here, I've got an answer of $17,595.65. Nice. Okay. Number 17 coming up. Number 17, 24,000 is invested for 2 years with an APR of 3%, daily compounding. N equals daily compounding is 365 times the number of years, which is 2. Interest is 3. Present value for this amount, for this investment, is 24,000. Payment is 0. Future value, that's what we're solving for. PY and CY. What's it going to be? If you're saying 365, you are correct. 365 each one. Go back up to this future value. And you are going to get 25,484 and 1 cent. Sounds reasonable to me. That's number 17. Okay, here's a little bit of a different problem. The parameters change on number 18. Suppose you start saving today for a $45,000 down payment that you plan to make on a house in 7 years. Assume you make no deposits into the account after the initial deposit. For the account described below, how much would you have to deposit now to reach your $45,000 goal in 7 years? Okay, so this is a case here now that it's changing. We're going to say if we need $45,000 in 7 years, that's the future value, the $45,000. We need $45,000 in 7 years, so that's going to be listed here, $45,000. Okay. It's an account with daily compounding at an APR of 7%. So the daily compounding here for 7 years, that's going to be 7 times 365. That's our N. Our interest is 7 for 7%. Our present value, how much do we have now? If I need it in 7 years. Present value, I don't have, that's what I'm going to figure out. How much do I need now to invest in this account if I need $45,000? Okay, how much should I invest? Payment is 0, does not apply. I'm looking for the present value. What's the present value here going to be? PY and CY, the daily compounding is 365. So we know that goes in these slots here. So my PV, present value, how much I need now, is going to be $27,569 and 48 cents. That's it. Keywords though, parameters changed. Future value is what we are looking at. So I need to solve for the present value. Number 19. You want to have $65,000 college fund in 14 years. How much will you have to deposit now under the scenario below? Assume you make no deposits into the account after the initial deposit. So here we go. We want $65,000 in 14 years. So here, future value, $65,000. 14 years. So my N is going to be 14 times how many compounds a year? Daily. So that's 365. Interest rate of 4. Present value, that's what I'm solving for. Okay, I shouldn't use a 0. Let's put a question mark to let you know that's what we're solving for. Or the box here. The payment, 0. PY and CY, 365 and 365. Yeah, so I'm solving for this. What's the present value? And when I hit alpha enter, I've got $37,129.73. That's how much I need to invest now if I want $65,000 in 14 years at 4%. Okay, here is a bit of a longer problem, so I'm going to break this up into the people involved in this and do them each individually, I think. So, in other words, I'll answer the questions here as we go, one person at a time. So this one, let's read this here. It says the following... hold on a second. There we go. The following pair of investment plans are identical except for a small difference in interest rates. Compute the balance in the accounts after 10 and 30 years. Discuss the difference. All right, let's start with Chang. This will be Chang here. I'll label him, then it looks like I'm going to have to erase it and do the other person. So Chang. Chang invests $800 in a savings account that earns 4.5% compounded annually. Okay, Keo invests $800 in a different savings account that earns 4.75% compounded annually. After 10 years, Chang will have a balance of approximately what? So let's do Chang first. So let's see, after 10 years, Chang, 10 Chang, do that, 10 years, then Chang is going to have 10, the N here for Chang is going to be 10 years times annually is 1. All right, so that's 10 years. The interest rate is 4.5% for Chang. His present value is his investment of $800. Payment does not apply. His future value, that's what we're solving for. PY and CY on this one is going to be 1 and 1. Okay? So after 10 years, Chang, his future value of that money is going to be $1,242.38. Okay? So let's see, after 10 years, Chang will have a balance of approximately $1,242.38. Oh, chicken scratch there. Okay. After 30 years, Chang will have a balance of approximately how much? So let's go back up. Everything stays the same except for the n. And the n is no more, it's no more 10, but it is 30. So I can cross this off, and make it 30 here, 30 here if I want to see that. And now once I go to future value here, that is no more. Let's get rid of that. That was the old amount for the 10 years. Be interesting. Could I multiply that by 3 and get the same answer? I don't know that, but something for you to investigate. So his future value then is, for the 30 years, after 30 years for Chang, is $2,996. $2,996.25. Okay, so that will go here. $29.96.25. There they are. Okay, so that part Chang is done. Okay, so let me clear the board without you waiting or watching. All right. Let's do Keo next. After 10 years, Keo will have a balance of approximately what? So same questions, and let's take her investment. Keo invests $800 in a different savings account that earns 4.75% compounded annually. All right, so no big deal here. So she's going to have what? N is compounded annually, so that's 1 times 10, which is 10. The interest for her is 4.75, slightly higher. See the difference that makes. The present value is 800, same investment as Chang. Payment does not apply, 0. Future value, that's what we're solving for. PYCY, compounded annually, 1 and 1. All right, so that means Keo earned $1,272, $1,272.42. After 30 years, okay, same thing. We're going to go back here and just change this number only, and this. Let's get rid of that. I think that's it. This is going to be 30. This is for informational purposes up here. 4.75%. And when you do that after 30 years, then Keo's going to have a balance of $3,218.93. Okay, so here, I'll put it here as well. $3,218.93. 93. That's her future value after 30 years. All right, so let's see what else we got. After 10 years, Kia will have how many dollars or what percent more or less than Chang? All right, so we know after 10 years, Kia's going to have more than Chang. Here's the 10 years here between Chang and Keo. Okay, there's you got to be careful with that. And the difference, if I subtract these, right? Let's see, she's going to have more, so it's going to be, I'll do it this way, minus the 1242. And you've got a difference of $30.04. Okay, if I want to figure that, what percent is that? What is the percent of that? After 10 years, Kia will have how many dollars or what percent more? You know it's more than Chang. What percent more? Well, we took the difference between the two, the 30.04, and we're dividing it by Chang's amount. Then Chang. 1242.38. So you take the difference of the two amounts and divide it by Chang's amount because it's comparing it to Chang. And you end up with a result of 2.42%. You know, 0.0242, but don't forget we're moving the decimal over 2 places to change it to percent. Okay, how about the same thing for 30 years? After 30 years, Kia will have how much more? Okay, so if you take the difference between Kia, which is 32, I'll write it out, 32.1893 minus the 2996.25, and you're going to get an answer of 222.68. That's the dollar amount. Okay, so that's the dollar amount, and then what percent more will Kia have? Okay, she still is going to have more. And how much more? Take the difference here, that 222.68, and divide it by Chang's $2,996.25. And the result there will be 7.43%. Okay, here's another 21. Forget what we go to, 28. Yep, 28. Okay, what do we got here? At age 19, someone sets up an IRA, individual retirement account, with an APR of 8%. At the end of each month, he deposits $100 in the account. Oh, there's something new, where we deposit money in an account each month. How much will the IRA contain when he retires at age 65? Compare the amount. Hold it. Okay, that's better. Where was I? Compare how much will the IRA contain when he retires at age 65. Compare that amount to the total deposits made over the time period. After retirement, the IRA will contain how much? All right. If you're 19, you set up an IRA, 8%, and you're retiring at 65. So I want to take that 65 and subtract 19 from it, and that's going to get me 46 years. So my n's going to be 46 times, what's the compounding? At the end of each month, he deposits $100 in the account. So he's got some payments here that he's doing. So the n is going to be 46 times 12. The interest rate is 8. The present value, when he's starting this, is 0. Yeah, there is no money. He's starting it out, starting with $100 a month. His payment here is going to be $100 because he's making $100 installment payments. The future value, that's what we're going to solve for. PYCY, well, we said it's going to be monthly, so the PY and CY are going to be 12. There we go. Everything's satisfied, and now I will solve for the future value. And the future value is going to be 572,477.40. Isn't that nice? Sounds nice. And very realistic. However, 8% is tough to get. Okay, nevertheless, that's that. How about this part here? The total deposits made over the time period. How much of that is his own money? This is an interesting number. So let's see. If he put in $100 each month for 46 years, the amount of his own money is going to be $55,200. Nice. And it grew to be that 572,477. Think about it, people. If you've got any money to put away, it doesn't have to be 100, and it doesn't have to be 8%. Do something. Even if it's $10 a month, come on. You'll do yourself a great favor after the end of the years that you are investing. All right, 21, next, 22. All right, you want to purchase a new car in 5 years and expect that car to cost $90,000. Wow. Your bank offers a plan with a guaranteed APR of 4.5% if you make regular monthly deposits. Okay, that's interesting. Regular monthly deposits. How much should you deposit each month to end up with $90,000 in 5 years? All right, let's go to it. Our N here is going to be 5 years times 12. Okay, monthly deposits. Our interest rate is 4.5. Our present value, we don't have any money. It's 0. Our payment, how much do we have to deposit to get that $90,000 in 5 years? This is the one we're solving for. Future value, that's our $90,000. PYCY, 12 and 12. Why is it 12 and 12? Monthly deposits. So our payment is going to have to be, alpha enter, $1,340.37. Okay. Easy, right? Doesn't take long at all once you get used to pushing these buttons, know where to go. Where do they belong? Okay, here's another longer problem, I guess. We gotta sort things, organize our work. Yolanda deposits $250 per month in an account with an APR of 3%, while Zach deposits $3,000 at the end of each year in an account with an APR of 3%. Okay, so let's see. Let's do this separately here. So here I got Yolanda, or Yolanda. First of all, she puts in $250 a month, per month. So that's like a payment of $250 per month with an APR of 3%. And let's see, what's the end going to be? After 12 years, the balance in Yolanda's savings plan after 12 years, what was it compounded per month? So this is 12 times 12. Interest is 3. Present value. She's starting off with 0. What's her future value going to be? That's what we're going to solve for. PY and CY. 12 and 12. Plug that in, and the future value for Yolanda here is the balance in Yolanda's savings plan after 12 years is this amount, $43,268.54. Okay. That is Yolanda. All right. Let me be right back. I'll set up Zach. Okay. Let's try Zach now. Zach deposits $3,000 at the end of each year in an account with an APR of 3%. Okay, so Zach did that for 12 years, the account. All right, so the N here for Zach would be he deposited it one time a year for 12 years, so that's 1 times 12. And this is no more. This isn't Yolanda anymore, this is Zach. Okay, interest rate for Zach is 3%. Yep, same percent. Present value, he started off with 0. His payment is $3,000. What's his future value? And his PYCY? Gotta be 1, because he's making 1 payment a year. Zach's balance is $42,576. $576.09. Which person deposited more money in the plan? Which person deposited more money in the plan? They deposited the same amount. Same amount. Okay, because if Yolanda deposited $250 a month, that'd be $250 times 12 for how many years? For 12 years. This equals 36,000. Well, if you were Zach, you deposited $3,000 a year for 12 years. And that gives you $36,000. Okay? All right, let's see this one. Consider a student loan of $12,500 at a fixed APR of 12% for 25 years Now we're going to calculate this monthly payment. Okay, let's do it. Calculate the monthly payment. So I've got a student loan of $12,500. That's going to be your PV each time for a loan. $12,500. Present value of your loan. Now, if I put in positive 12.5, your answer is going to come out negative, which you will ignore. Just like you have all these problems. I should have told you this from the beginning. Oh my God. So don't worry about that negative sign. Consider a loan, calculate the monthly payment. All right, so we've got for 25 years, so our N is going to be 25 times the 12. 12 months, 25 years. Interest rate is 12. Payment, that's what we're solving for this time. Our future value. Think about it. On a loan, you always want that future value to be what? What number? 0 at the end of it. It always will be. Okay. PY and CY for loans are always 12. Monthly payments every month, 12 months in the year. All right, go back up to the payment. Let's solve for the payment. And you should get a payment of $131.65. I'll just put the answer right here, 131.65. Okay, that's what the payment is. Good enough? B, the total payment over the term of the loan is, what's the total payment over the term of the loan? I mean, how much of your own dollars did you put in? All right, so let's see, what do we got? The payment is $131.65. That's of your own money, right? And that's going to be times 12 months out of the year times the 25 years. Okay, so the total amount that you paid is $39,495. The total payment over the term of the loan, $39,495. And what was that loan amount? $12,500. You put in $39,000. Quite a bit. Now this is important here. C, of the total payment over the term of the loan, what percent is paid toward the principal and what percent is paid toward the interest? Okay, so this is easy once you grasp the idea of this is the total number of dollars that you spent altogether. Okay, so if we're looking for a percent, this part is going to be my denominator, the $39,495. Okay, what percent is paid toward the principal? All right, what was the principal amount of the loan? It was this $12,500. That's going to be your numerator. Okay? And when you calculate that out, it comes to 31.6%. Okay, just plug this into your calculator. 12,500 divided by 39,495, it gets you 31.6%. Okay. What percent is toward the interest? All right. So if you think about the whole loan itself, the whole loan compromises 100% of the loan, the amount paid back. 100% of the loan is paid back, including your interest. So if 31.6% is paid toward the principal, well, how much is paid toward the interest? It has to be the 100% minus the 31.6. And that number will get you 68.3%. And that's what you want. You want these two percentages to add up to be 100%. So if you figure out the principal amount, which is easy to do. By putting the principal of the loan divided by the total number of dollars paid, you get 31.6%. The other remaining percentage is going towards the interest. So just subtract 100 minus the 31.6% to get your interest amount. Okay? Probably try another one here. Okay, here's another one. Consider a home mortgage of $150,000 at a fixed APR of 9% for 25 years. Home mortgage is the loan. Calculate this monthly payment. Okay, so let's calculate the monthly payment. I've got N is 25. Oh, just had that, didn't we? 25 times 12. Okay, the interest rate is 9. The present value of the loan is the amount of the loan, $150,000. The payment, that's what we're going to solve for. Future value, we want it to be 0. After 25 years of making payments, your house will be paid for. PYCY, 12 and 12. They're loans. So our payment becomes, for number 25, our payment amount is $1,258, $1,258.79. Remember, we want that change in there. All right, the monthly payment is this, $1,258.79. Determine the total amount paid over the term of the loan. So I could take this, 1,258.79. I'll do this one. Times 12 times 25. Okay. And that we got 377,637. 377,637. And C, of the total amount paid, what percentage is paid toward the principal and what percentage is paid for interest? All right, so here I've got my total amount of dollars that I spent. That's going to be my denominator. I'll go through this. It's my denominator. And it's 377,637. My numerator is going to be the principal amount, which is $150,000. Because what am I figuring out? What percentage is paid toward the principal? So there's my 150 divided by 377, and that ends up being 39.7%. And what percentage is paid for interest? Well, if this is for principal, the interest amount is going to be the 100 minus 39.7%. And that comes to be 60.3%. Okay, nice. Nice job. Suppose that on January 1 you have a balance of $3,200 on a credit card whose APR is 12%, which you want to pay off in 1 year. Assume that you make no additional charges to the card after January 1. Calculate your monthly payment. Okay, here we go again. It's redundant after a while. Let's see, we've got, what's N going to be? N is going to be 12 after 1 year. It's a loan. 12 times 1. We'll pay off in 1 year. I, the percentage, is 12. PV, the present value of the loan, is $3,200. The payment, that's what we're figuring out. Got to figure out what the payment is going to be. Future value, like any loan, 0. PYCY, you got it, 12 and 12. Okay, so that monthly payment then is going to end up being $284.32. $284.32. What was the total paid since the total paid since January 1 is how much? All right, how much money did you pay total? So it's 284.32 times 12. What was that amount? $3,411.84. What is the percentage of the total paid that is interest? What is the percentage total that was paid that was interest? Well, in order to find that, we have to take the total amount paid and subtract it, or subtract the present value of the loan, which is $3,200. Okay, so here it's going to be the 34. Let's see if I'll do it this way. Let me bring it down here. So I've got 3411.84, and then I'm going to subtract the principal amount, which was $3,200, and I get a number that is $211.84. Okay, and I want to take that $211.84, and I want to divide it by the 3,400. The total amount paid. That was the interest. And when I do this division, I end up with 6.2%. Okay? And that the percentage of the total paid that is interest is this. You know, you could have, maybe it's a little bit easier if you understand this. I hate to bore you with this though, but if I knew this amount here, right, from we calculate what our total amount was, this 3411.84, and it's readily available to us the amount of the loan, which was $3,200, which is the principal. So how much of the principal, the percentage of the total amount paid that is principal, what is that percent here? Okay, let me grab this, and it would be, when I calculate this out, I got 3,200 divided by 3411.84, and when I do that, I end up with 93.8%, which again, this is the principal amount, the percentage of the principal that was paid, and if I subtract 100 minus 93.8, I get the 6.2%. So this may be just a little bit easier with that one other step to add to, which is kind of easy. We use in our calculator. Okay, next. right, let's see what we got here going. Compare the monthly payments and total loan costs for the following pairs of loan options. Assume that loans are fixed rate and have the same closing costs. All right, you need a $100,000 loan. Option 1, 30-year. So let's make this one option 1. And this option 2. Okay, so we got a 30-year loan, APR of 9%. So N here is 30 times 12. Interest rate is 9. Present value is going to be the amount of the loan, which is $100,000. The payment, that's what we're probably solving for. Yep, the monthly payment here. Future value 0, PYCY 12 and 12. Okay, so we've got the first payment here is $805. Remember, that is alpha enter to get your 805. Let's do the option 2 payment. That's a 15-year loan, so that's going to be 15 times 12. I is going to be, the interest is going to be 8.5%, so you save a little bit there. What's next? Present value, 100,000. Payment, solving for. Future value 0, PYCY 12 and 12. Our payment on that loan is going to be, I'll put it over here, payment here, I can squeeze it here, $985. Alright, that's our payment for the 15-year loan. So let's write that here as $985. Find the total amount paid for each option. So the total amount paid for option 1 is, what do we have here? 30 years, 12 months out of the year, times 805. And what does that get you? 289,800. 289,800. Total payment for option 2 is going to be the 15 years times the 12 months out of the year times the higher payment of $985, and that's going to get you a payment or a total amount paid of $177,300, which is substantially lower, right? You're doing it in half the time, so that's how much money you save over the course of those following 15 years. Alright, it says compare the two options. So let's see, can I drag this up here? Compare the two options. Which appears to be the better option? And I guess it would be D, option 2. Okay. You can read that. All right, let's do the last one. Looks similar to number 27. You need a loan of $175,000 to buy a home. Calculate your monthly payments and total closing costs for each choice below. Briefly discuss how you would decide between the two choices. All right, so we got something new here with what is called points on a loan to help save you some money. Alright, so we got to figure out what is the monthly payment for choice 1. So let's call this one over here choice 1. I'll label it here. This choice 2. Okay, so choice one, we got a 15-year fixed rate at 5% with closing costs of $1,800 and no points. All right, so our N is going to be 15 times 12. Our interest rate here is 5. The present value of the loan is $175,000. The payment, that's what we're solving for. Future value 0, 12 and 12. Okay, so we've got a loan here of a loan payment for the choice one is, okay, let's write it here, $1,383.89. What is the monthly payment for choice two? All right, choice two, here it is. I've got 15 times 12. Interest rate is a little lower because of the points. 4.5% is the interest rate as opposed to the other one, which was 5. Present value of the loan, $175,000. Payment, that's what we're solving for. Future value, PYCY, both 12 again. So what's our payment on the second one? The payment on the second choice is $1,338.74. Little bit less. Oh, forgot I was going to write it over here. $1,338.74. What is the total closing cost for choice one? And choice one had closing costs of $1,800 and no points. So that means it's $1,800. You're going to want to remember this for points, what they're talking about for the project, the home project, part 4, I think it is. So keep this in mind. This is important for you to figure out that portion of the project. What is the total closing cost for choice 2? All right, so let's see. Choice 2, the closing costs are the $1,800, and then we've got to add 2 points, which means for every point of a mortgage, it's 1%. So 1% of $175,000 is how much? $1,750. But it's 2 points, so it would be 2% of $175,000. So let's see, I'm going to have $175,000 times 0.02. And that should get you $3,500. So that's part of your closing costs. And the trade-off is banks do that. They'll offer you 2 points and they'll shave off a half a point for the mortgage in this case. Usually each point, realistically, each point will lower your percentage of the loan by 1/4%. So these are the things that are variables that you weigh. You're buying a house that you're going to stay in there for 30 years, you may want to consider this. If you know you're going to be there 5 years, then you don't want to do that. Okay, anyway, the total closing cost here ends up being $5,300. Did I go over? What happened here? Oh, let me scoot that up here. There's your 5,300, and then we've got the rest of this. Why might choice 1 be better choice? Well, the last 2 are A's. I didn't even put up the last question. Or why might choice 1 be better choice? A. And then why might choice 2 be the better choice? And that was A also. you can look that over. That's something you have to determine and understand on your own. Okay, that's it for chapter 4. Man, that was a long one, but we got it in, and I hope this helps you to do your assignment. Okay, goodbye.